Roman aqueducts are among the most successful engineering systems ever built. Nearly 2,000 years ago, Roman engineers transported enormous quantities of fresh water across long distances without electricity, without pumps, and without modern instruments. This was not a minor technical achievement. Entire cities depended on these systems for drinking water, sanitation, and public life. In this episode, we'll explore how Roman engineers solved the problem of moving water using careful measurement, geometry, materials, and gravity, and why their solutions still matter today. As Roman cities grew, local wells and springs could no longer supply enough water for their populations. Urban centers required large, continuous supplies of clean water for drinking, cooking, public baths, fountains, and sanitation. Rivers were often distant or contaminated, and lifting water mechanically over long distances was impractical with ancient technology. The fundamental challenge facing Roman engineers was not finding water, but transporting it reliably day after day into dense urban environments. The Roman solution was elegant in its simplicity. Water naturally flows downhill, so aqueducts were designed with a continuous, gentle slope from the source to the city. This slope had to be extremely precise. If it was too steep, the flowing water would erode the channel. If it was too shallow, the water would slow down or stop entirely. By carefully controlling this gradient, Roman engineers allowed gravity to move water over miles without any mechanical assistance. Maintaining a gentle slope over many miles required remarkable precision. A small surveying error could cause water to pool, overflow, or fail to reach its destination. Roman engineers relied on careful measurement rather than trial and error. They used instruments such as the chorobates, which allowed them to establish level surfaces using water or plumb lines. This was engineering as a disciplined practice based on observation, measurement, and repeatability. Wherever possible, aqueducts were built underground. This protected the water from contamination, reduced evaporation, and stabilized the temperature. When valleys or uneven terrain intervened, Roman engineers constructed long rows of stone arches. These arches distributed weight efficiently, allowing aqueducts to cross wide gaps while remaining stable for centuries. The familiar arcades we see today are only the most visible parts of a much larger system. Roman engineers made extensive use of concrete, which allowed them to build strong, durable water channels. The interiors of these channels were lined with waterproof mortar to reduce leakage and maintain water quality. Flow was also carefully managed. Settling tanks allowed sediment to fall out of the water before it entered the city, improving cleanliness and reducing maintenance. Every part of the system was designed with long-term operation in mind. The scale of Roman aqueduct systems was extraordinary. The city of Rome alone was supplied by 11 major aqueducts, some extending more than 50 miles from their sources. Water flowed continuously, day and night, supplying public baths, fountains, and private homes. This was not an experimental technology. It was a fully integrated infrastructure network supporting one of the largest cities of the ancient world. Reliable water supplies transformed Roman urban life. They improved public health, enabled dense populations, and supported institutions such as public baths and fountains. More importantly, aqueducts demonstrated that large-scale engineering systems could be planned, built, and maintained long before modern science formally existed. They represent a shift towards systematic problem-solving at a societal scale. Roman aqueducts remind us that engineering is not defined by electronics or machines, but by careful thinking, measurement, and design. Some of these systems operated for centuries, and their basic principles are still used in modern water engineering today. In future episodes, we'll explore other engineering marvels of the ancient world and the ideas behind them that shaped how humans learned to build, measure, and control their environment. Thank you for watching.